In order to maximize performance and parallelism, the AVR uses a Harvard architecture with separate memories and buses for program and data. Instructions in the program memory are executed with a single level pipelining. While one instruction is being executed, the next instruction is prefetched from the program memory. This concept enables instructions to be executed in every clock cycle. The program memory is in-system reprogrammable flash memory. The first access registers file contain 32 into 8-bit general-purpose working register with a single clock cycle access time. All the configurations in microcontroller is set through 8-bit 1 byte location in RAM and RAM in a bank of memory bytes of microcontroller called as register. All the functions are mapped to its location in RAM, and the value we set at that location, that is at that register, configured the functioning of microcontroller. 6 of the 32 registers can be used in 3 16-bit indirect address register pointer for data space addressing, enabling efficient address calculation. One of these address pointers can also be used as an address pointer for lookup tables in flash program memory. These added function registers are the 16-bit X register, Y register and Z register. I will describe it later. So as register size of this microcontroller is 8-bit, it is called as 8-bit register. The ALU supports arithmetic and logical operations between register or between a constant and a register. Single register operation can also be executed in the ALU. After an arithmetic operation, the status register is updated to reflect information about the result of the operations. So the status register contains information about the result of the most recently executed arithmetic instruction. This information can be used for altering program flow in order to perform conditional operation. The status register is not automatically stored when entering an interrupt routine and restored when returning from an interrupt. This must be handled by the software. So here you can see in front of you it is a 8-bit status register. So I will describe you the pin one by one. So the bit 7 is I, means it's a global interrupt enable. Global interrupt enable bit must be set for the interrupt to be enabled. The individual interrupt enable control is then performed in separate control register. The next is the bit copy storage. So this pin is denoted by T. The bit copy instruction BLD and BST use the T bit as source by destination for the operated bit. Next is the half carry flag. This is the half carry flag indicates a half carry in some arithmetic operation. Half carry flag is useful in BCD arithmetic. The next is S bit is always an exclusive, or you can say a sign bit. Next is you have a 2's complement overflow flag. So this bit 3 is a the 2's complement overflow flag. We support 2 complements arithmetic. The next is the negative flag. Negative flag. So this negative flag indicates a negative result in the arithmetic or logical operation. Next is the zero flag. This is a zero flag which indicates the zero result in arithmetic or logical operation. And the last one is the carry flag. The carry flag indicates a carry in an arithmetic or logical operation. So this is the way you can see the status values of your arithmetic and logical operation. Next is general purpose register file. So the register file is optimized for the AVR enhanced RISC instruction set. In order to achieve the required performance and flexibility, the following input and output schemes are supported by the register file. So in this you have one 8-bit output operand and one 8-bit result input. Next you have two 8-bit output operand and one 8-bit input operand, and the next is you have again two 8-bit output operand and one 16-bit input operand. You have again one 16-bit output operand and one 16-bit input operand. So in this way you have a general purpose registers as shown in figure. So you can see Each register is also assigned a data memory. This is a data memory address, mapping them directly into the first location as a user data space. Although not being physically implemented as a SRAM location, this memory organization provides great flexibility in access of the register as the X pointer, Y pointer and Z pointer. So in this way you can use the registers. The register R26 to R31 have some added function to their general purpose usage. These registers are 16-bit address pointer for indirect addressing of the data space. So in this way you can use the registers and how the registers of the 8 mega 8 are working.